In this problem, we are given the following circuit diagram, and then we are asked to use node voltage method to find V1 and V2 in this circuit. Below, I have placed an example as well as the equations to solve this example, and we're going to be using this as kind of a base to do this big problem right here. First thing that we should notice is the distance between our voltage 1 and our voltage 2. They're pretty far apart, unlike in this example where they're right next to each other, right here and right here. We can also notice that what's separating them is a resistor right here, this 80 ohm resistor. That's actually in parallel with this 120 ohm resistor. So what we can do is put these into the parallel resistance formula. This formula is just 1 over the first resistor plus 1 over the second resistor, which is 120, all raised to the negative first power. And if we do this, we're going to see that we have 48. So the resistance for here is going to be 48 ohms when we combine them together. I've gone ahead and redrawn our circuit diagram with our 48 ohm resistor in place of our 80 and 120 ohm resistor. Now we can begin and start solving this. So the first thing we need is a first node. This node is going to be right here. Next we need our second node, which is going to be right here. Going into this node, we have this 6 amp current right here. It's going in this, and then it's going to split in parallel with this resistor and then this 8 ohm resistor right here. That means the current through these two resistors are both going to have to add up to equal 6 amps, since 6 amps is going to be divided into these resistors based on their resistance. So we're going to say 6 amps and completely ignore this first step where we have the V1 minus Vs over the first resistor, because we don't have a first resistor. We just have this amperage that it's equal to. 6 amps is equal to, and now we look at V1 over R1 because we're looking at this part that's going down here. So we have V1 over the 40 ohms plus a V1 minus our V2 over 8 ohms. And we have V1 minus V2 because we have this 8 ohm resistor right here. And since they're in parallel, the resistance will be different. And since they're in parallel, the current will be different, which is why we are subtracting some of the voltage over the 8 ohm resistor, because there is some current loss over the 8 ohm resistor. I'm going to move the 6 over to the right side just so it's a little bit more uniform. We can see here that we have two unknowns, a V1 and a V2. So now we need a node 2 formula. Looking at this node 2 right here, we can see that we're going to need a V2 minus a V1 over the 8 ohm resistor. Next we're going to calculate for our V2. So we're going to have a plus V2 over the 48 ohm resistor. And lastly, we have current 1 amp that's actually going out of this. So this is just going to be minus 1 amp. And at this node, this is all equal to 0. Now we can start simplifying some things. So what I'm going to do in here is multiply everything by 48 ohms to get rid of the denominator. And over here, I'm going to multiply everything by 40 ohms to get rid of the denominator. And then I'm just going to combine like terms. After we do that, we're going to get these two equations. From here, we can see that we have a couple similar things, which is this V1 right here. So we have this 6V1 and this negative 6V1 right here. Well, since these are just the opposite of each other, we can add these together to get rid of this 6V1. After we do this, we're going to get 2V2 is equal to 192. If we divide this, we're going to get that our V2 is equal to 96. And this is our answer for V2. Now that we found V2, we can find V1. We could plug our V2 into either of these formulas. I'm just going to do it for the first one. If we do this, we're going to get 6V1 minus 5 times 96 is equal to 240. If we care about units, this should be surrounded, and this will be volts, and this will also be volts. If we multiply 5 and 96 together, we're going to get a negative 480. Then we're going to add 480 to both sides, and then we get 720. So we're just going to get 6V1 is equal to 720 volts. We can divide both sides by 6 to get V1 by itself. And then if we do this, we're going to get V1 is equal to 120 volts. This is the answer for V1, and that is how you do this problem. If you want more problems like this, there's a playlist linked below with a bunch of problems related to circuit analysis. There's also notes that I use to do these problems as well as study for exams.